Okay, let's move on to another problem. Here, let's look at the integral of tangent to the third power x dx, the integral. Okay, so here I'm just going to straightforwardly use my reduction formula. Reduction formula says it's the integral of tangent of 1 power smaller, so tangent squared x over that power, right, minus the integral of tangent of 2 powers smaller. So that would be minus the integral of tangent x dx. And then that's one we remember, right? That's the negative ln of cosine. So that's going to be minus the negative ln absolute value of cosine x, and then plus a constant. So simplifying it, that'll be tangent squared x over 2 plus the ln absolute value of cosine x plus a constant. Okay, so pretty straightforward. Pretty straightforward process. And this brings us to our next idea. If it's just a single power of cosine or secant, I didn't do any of those, but we would just, for the most part, use our reduction formula. Right, we already know secant squared is just straight tangent. So starting with secant cubed, you would just be making use of this reduction formula as you go on. Okay. So same kind of idea as what we just did with the tangent. So if we just have a single tangent or a single secant, for the most part, this is kind of how we can handle it. Now there is some other things we could do that maybe speed the process up, and maybe we'll see an example or two of that a little later. But our main focus now wants to turn to the problem of what if we have integrals involving tangent and secant together? Tangent and secant together. So in other words, we have tangent to the m, so some m power for tangent, and secant to the n x dx. Well, it depends on what we have. It depends on what we have here. If we have an even power on the secant, so if n happens to be an even power, so if n is even, then what we do is we strip off a secant squared so that we can use that with u equals tangent x. And then the remaining secants, if you took off an even power, you still have an even power, then they're all some power of secant squared since they're even. So you can turn all your other secants into tangents, and then you can use that substitution, u equals tangent, you'll have the secant squared left over, and then you work that way. If, on the other hand, the power on the tangent turns out to be odd, then we strip off a tangent x secant x to use with a u equals secant x substitution. Because you're going to have a secant here, right? The whole idea here is that you have a secant and you have a tangent. You have a secant and you have a tangent. Okay. You have one of them, right? You have one of them. So if you have an odd power on the tangent, then take your tangent, one of the tangents, which will now make the tangent an even power, and then group that with one of the secants. It doesn't matter what the secant is in this case. And then you can take the remaining tangents, which will now be a tangent to an even power, And being an even power, you can convert all those over to secants so that you can use the substitution. So that's the idea. If the secant has an even power or the tangent has an odd power, life is great. And then if it turns out that the secant's power is odd and the tangent's power is even, if the secant power is odd and the tangent power is even, then you just have to scream. You just have to scream. That's it. Ah! Right? Because it's going to be horrible. You're going to have to then convert your tangents over to secants, and then you're going to have to use a bunch of, or as many secant reduction formulas as you need to. You'll have to put everything together, and you'll have a bunch of secant powers, and then try to use a reduction formula to get yourself somewhere. That's really the only option there. Okay. This is the best case scenarios when we have one of these, or both of them, then we have a choice. But if it turns out secants to an odd power and tangents in an even power, then just scream, because you're going to have some work ahead of you. First, you're going to have to get it all in terms of secants, and then you're going to have to use a reduction formula maybe several times. Okay, so that's just kind of a preview, a little introduction of what happens with a mix of tangent and secant. And we're going to do a couple examples with a mixture of tangents and secants. And yes, we will do one of those. Unpleasant ones at some point where we do run into this situation. Okay, I'll show you how to handle that.